Welcome to online class of New Vivekanand Convent Higher Secondary School, Kusakala Kharsia. Today we have learned class 9 science. Chapter name is Hydrocarbons. First, we know about hydrocarbons. What do you mean by hydrocarbons? Basically, the chapter hydrocarbon is based on hydrogen and carbon. So, first we know about carbon. First we know about carbon, then we explain the full chapter. Let's start from carbon. Carbon whose atomic number is 6. In the previous video, in chapter atomic structure, we explained atomic number, electronic configuration and valency. Here we also do the same things. First, carbon whose atomic number is 6 and electronic configuration 2, 4 and electronic configuration is 2, 4 and valency equals to 4. Valency form means the carbon atom combined with 4 another atoms. Carbon atom can form 4 bond with other atom. Here in this chapter hydrocarbon, carbon atom combined with hydrogen. Basically in this chapter, the carbon atom combined with hydrogen atom. Carbon atom combined with 4 hydrogen atom. Let's carbon atom combine with 4 hydrogen atom. See like this. First, after this we explain some another property of carbon. That is catenation property. What do you mean by catenation property? Catenation property means bond itself to form a long chain. Catenation property means bond tendency to bond itself to form long chains. Bond itself means bond with another carbon atom. Bond itself means bond with another carbon atom to form a long chain of carbon like this. Let's carbon bonds with itself means carbon again bonds with carbon against bonds with carbons and go on. ऐसे क्या होगा चलते रहेगा. अब we know that the valency of carbon is 4, so we fill the valency of carbon here. Carbon from 1 bond, 3 bonds is remaining and 3 bonds is filled by hydrogen atom, 3 hydrogen atom. And next carbon, here 2 bonds is formed by carbon atom, so 2 bonds is remain which is formed by hydrogen atom. And next carbon also form 2 bonds with 2 carbon atom and 2 bonds remain, that is filled by hydrogen atom. And last carbon also form 1 bond with carbon atom, so 3 bonds remain, 3 bond is filled by 3 hydrogen atom. Like this form a long chain of carbon atoms. Here only 4 carbon, it's maybe 5, 6, so on. Next property of carbon. Next we know how the carbon containing compounds, carbon chain formed by this catenation property, naming this carbon containing compound. What is the rules of this naming? First we know about the roots and prefix. What are they? What are roots and what are prefix? Roots क्या होते हैं और prefix क्या होते हैं? we know the hydrocarbon basically in this chapter three types. The hydrocarbon basically is three types for class 9th base. What are they? They are alkane, alkene and alkyne. Alkane, alkene and alkyne. Where alkanes means carbon-carbon single bond. Where alkanes means carbon-carbon single bond. Alkene means carbon-carbon double bond. And alkynes means carbon-carbon triple bond. Again I repeat, alkanes means carbon-carbon single bond, and alkene means carbon-carbon double bond, and alkynes mean carbon-carbon triple bond. Where carbon-carbon single bond, I mean alkane, is called saturated hydrocarbon. This is called saturated hydrocarbons. And carbon-carbon double bond and carbon-carbon triple bonds are called unsaturated hydrocarbon. Carbon-carbon double bonds and carbon-carbon triple bond is called unsaturated hydrocarbons. Again I repeat, carbon-carbon single bond is called saturated hydrocarbons, and carbon-carbon double bonds and triple bonds are called unsaturated hydrocarbon. Now we naming the alkane, alkene and alkynes one by one. For the naming, we first know about roots and prefix. First we know about roots and prefix. What are the roots and prefix? Roots root and prefix, suffix. Roots and suffix. First, root. Actually roots means क्या होते हैं? कोई पेड़ का roots means क्या होते हैं? जड़ होते हैं, जो मेन चीज, जो क्या करते हैं? पूरा पेड़ को पकड़ के रखता है. Here also roots mean the whole hydrocarbons is based on these roots. Whole hydrocarbons, whole compounds, whole chain is based on this root. What are they? If carbon is 1, if number of carbon is 1, then root is mid. If carbon is 2, then root is it. If carbon is 3, then root name is prop. If root is 4, carbon is but. If carbon is 5, root is pent. If carbon is 6, root is hex. If carbon is 7, root is hept. If carbon is 8, root is oct. If carbon is 9, root is non. And carbon is 10, root is deck. Then suffix. Suffix means which is add after any words. Suffix क्या है? कोई भी word के बाद में add किया जाता है. So here we also know some suffix. Like carbon-carbon single bond, we add suffix ane, n. Again I repeat, for carbon-carbon single bond, we add suffix ane, n. For carbon-carbon double bond, in. Again I repeat about suffix. Suffix means after. Suffix means after. क्या होता है? after add होता है, कोई भी वर्ड का बाद में ऐड किया जाता है suffix. Here we also add suffix in, and while, in. Where we add in, where, in, and where, in. We know from this that when carbon is single bond, then we add in. When carbon is double bond, we add in, and carbon is triple bond, we add in. Carbon single bond, we add in. Carbon double bond, we add in, and carbon triple bond, we add in. Now we write the name of alkane, alkene, and alkyne. How we write the name of it? Alkane, alkene, and alkyne from this roots and suffix. Let's start from alkane. Alkanes means carbon single bond. Alkanes mean carbon single bond, and general formula is CnH2n plus 2. If you forget this, you can make yourself by the following way. How? Let's say alkane is CH3 single bond CH3. How we generate a general formula of alkane? Here carbon number is 2. Here carbon is 2. I mean Cn means 2. H2n. In all the cases of alkane and alkene and alkyne, Cn H2n be common. In the all cases of alkane and alkynes, Cn H2n is the common of in general formula. Common in general formula of all alkane and alkyne. Next, how to calculate general formula of alkane from this? Here the carbon number is 2. So we put and 2. Then 2n means 2 into 2. I mean 4. But hydrogen is 6. So we add plus 2. I mean general formula becomes CnH2n plus 2. Again I repeat. If we forget the general formula, any of them, I mean alkane and alkynes, we also make yourself. How? What is the trick of this? First, CnH2n be the general formula for alkane, alkene, and alkyne. The CnH2n be the common for general formula of alkane, alkene, and alkynes. We add plus 2, minus 2, and 0. Where we add plus 2, where we add minus 2, and where we add 0. Let's start from this. This is the simple example of an alkane. CH3, and single bond is present. That means it is an alkane. Alkanes means CnH2n common. Number of carbon equals to 2. We put carbon number, I mean n equals to 2, and H2n, 2n means 2 into 2, I mean 4. But here hydrogen is 6. I mean we add plus 2 to fulfill this. I mean the general formula becomes CnH2n plus 2. In this way, we can easily generate a general formula of alkane. Now we explain the nomenclature of alkane. Let's a simple example of alkane. Here the number of carbon is 2. Number of carbon is 2. 2 means number of carbon, 2 means root here it is a alkane. I mean suffix is N. We add N, A-N-E. I mean the name of this hydrocarbon, I mean name of this alkane is ethane. Again I repeat, here the number of carbon is 2. 2 means root is it. We write it. Next, here the hydrocarbon is alkane. I mean suffix is N. We add N suffix. And the name of this hydrocarbon is ethane. Next, and another example, we explain 2 or 3 examples to explain this nomenclature. Next, another example. Here, number of carbon 1, 2, 3, 4, 5. 5 means root is pent. Then it's a hydrocarbon because the carbon-carbon single bond is formed here. That means the suffix is N. We add N. Then the name of this hydrocarbons, I mean alkane, is pentane. Let's another example. Number of carbon 1, 2, 3, 4, 5, 6, 7. Again I repeat, number of carbon 1, 2, 3, 4, 5, 6, 7. 7 means hept. Root is hept. Then we add suffix. What is the suffix for this? Because this is a hydrocarbon. That means suffix is N. So we add N. The name of this hydrocarbon is heptane. Name of this hydrocarbon is heptane. Okay, student? I think all of you understand this. Next, we explain alkene. Explain the nomenclature of alkene. Alkenes means carbon-carbon double bond. Alkenes means carbon-carbon double bond. Carbon-carbon double bonds. And general formula is CnH12. Again I say that if you forget this, how to create this formula? Same formula, Cn and H2n be the common. Let's a simple example of alkene. This is a simple example of alkene. Where we say this is alkene because here carbon-carbon is a double bond. Here the carbon-carbon forms double bond. The number of carbon is 2. I mean N is 2 and hydrogen 2 and 2 into 2. I mean C2H4. Here hydrogen also 4. That means we cannot add anything. I mean we add 0. And general formula becomes CnH2n plus 0. I mean CnH2n. Next, we explain the nomenclature of this. Nomenclature of alkene. Let's start with the example. CH2 double bond CH. Bond CH2, bond CH3. Numbering 1, 2, 3, 4. Here number of carbon is 4. I mean root is but. And here double bond is present. I mean this is the alkene. Alkene means suffix is in. So we add in. The name of this hydrocarbon, I mean alkene, is butene. And another example, take another example of alkene, and the example is CH3, CH double bond CH, and CH3. Here it should be noted that if the the double bond is present in first position. I mean C1 carbon. I mean carbon 1. The double bond is present in first carbon. Then we can add any number to explain the double bond is which position. Again I repeat, if the double bond is present in C1 position, I mean first carbon, then we can add any number to explain the positions of double bond. But if the double bond is not in first position, if the double bond is not in first position, if the double bond is another the first position, maybe second, third, fourth, then we must add the number to say the exact positions of double bond. Again I repeat, if the double bond is not in first position, if the double bond is in position 2, 3, 4, then we must write the number where the double bond is present to explain the position of double bond. This is the example of this types where double bond is not in first position. Let's start from numbering 1, 2, 3, 4, 5. And we also know that the numbering should be start from those sides where double bond is first. Where we get double bond is first. Again I repeat, we write the numbering of this from which side where double bond is first. Where double bond come first. Where double bond is come first. Here the double bond is second position, this side, so we write the numbering from this side. Let's number of carbon is 5. Number of carbon 5 means root is 10. Number of carbon 5 means root is 10, and it's a alkene, I mean suffix is in, and the position of double bond is 2, so we must write the number 2 in to say the exact positions of double bond. It means 2 means the double bond is present in number 2 carbon. Next, another example. Another example of alkane is first numbering. From which side we start the numbering? If we start this side, 1, 2, 3. I mean 3 position with the double bond. 3 position is the double bond. If we start this side, 1, 2, 3. I mean 3 position is the double bond. So we can numbering from this side or this side. This may be same numbering of double bond. So we start from this side. You may start from this side also, because the numbering of double bond is 3 for this side and from this side. Okay. Here number of carbon is 6. So root is hex and suffix carbon double bonds, I mean alkene, we add in. The name of this alkene is hex in. Next we explain the nomenclature of alkynes. We explain the nomenclature of alkynes. I mean carbon triple bonds. Carbon triple bond, and general formula is CnH2n minus 2. Again I say the same things. If you forget this, you can make yourself. How? The simple example of alkene is CH triple bond CH, and we know that CnH2n with the common for all of this. Then number of carbon is 2 C 2 H 2 into 2. I mean 4, but here hydrogen is 2. So we should minus the subtract 2. We should subtract 2. That means the general formula becomes CnH2n minus 2. Now we explain the name, nomenclature of alkynes. Let's start from this example. Here we also remember this, that the numbering will start from those sides where the triple bond is come first. Here we should remember this, that the numbering of carbon should be start from those sides where triple bond is come first. So here triple bond is come first. From this side we numbering this side 1 2 3 4. Number of carbon is 4. I mean root is but, and carbon triple bond, that means alkynes. We add suffix and I mean the name of this hydrocarbon, I mean alkyne, is butane. Another example is first numbering. From those side we numbering this. From this side the triple bond is come in 2 position, and if we numbering from this side, triple bond is come from in 3rd position. So we see numbering from this side, I mean 1 2 3 4 5. Root is 5 and number of carbon 5 means pent, and triple bond, I mean suffix is ine. So name of this hydrocarbon is pentane. Name of this alkyne is pentane. Now we explain how to structure of any alkane. If name of the alkane is given, again I repeat. Now we explain how to write the structure of alkane, alkene, and alkyne if their name is known. Let's start from an example. Let the name of the alkane, I mean name of the hydrocarbon. We don't say that alkane, alkene, alkyne, because if we write the name, you can easily say that it is alkane and alkynes or alkenes. Let's start from an example. Butene. Butene. In means it's a alkenes, because we add in alkenes, because we add the suffix in alkene, so it's a alkene. Now but means 4 carbon. First we write the 4 carbon. 4 carbon 1 2 3 4. Next in means double bond. If they do not mention any positions of double bond, if in question do not mention any positions of double bond, then we must write the double bond in first position. Again I repeat, if in question do not mention the positions of double bond, we write the double bond in the first position. So we write double bond in first position. And other carbon must be single bond. And other carbon must be single bond. Next, we fill the valency. We know that the valency of carbon is 4. We know that the valency of carbon is 4. And we first say that we must fill the valency of carbon with hydrogen, because the chapter name is hydrocarbons. So we fill the valency of carbons with hydrogen. Here the carbon form 2 bonds. I mean 2 bond is left, 2 bonds is filled by hydrogen. For this carbon it forms 3 bond. Here 2 and 1 is total 3 bond formed. So one bond is left which is formed with hydrogen atom, and next carbon form 2 bonds. I mean 2 bonds is left. That is formed filled by hydrogen atom, and the last carbon form only 1 bond. I mean 3 bonds is left, that is filled by hydrogen atom, and the structure of this alkenes become CH2 double bond CH single bond CH2 single bond CH3. Let's take another example. Let's take another example. Oct N. Again I repeat, this is the alkyl alkynes. We easily say that it's alkyne. How? Because the suffix is N. The suffix is N means it is a alkane. Suffix N means it is a alkane. And oct means number of carbon is 8. So let's write the first. Let's write 8 carbon. 1, 2, 3, 4, 5, 6, 7, 8. Next, N means carbon single bond. So write single bonds up. Next, fill the valency of carbon. Again I repeat, the valency of carbon is 4, and in this chapter we fill the valency of carbons with hydrogen. Here carbon from 1 bond and 3 bond is left, which is formed with hydrogen atom, and this carbon from 2 bonds. 2 bonds is left, 2 bonds formed with hydrogen atom, and this carbon also formed 2 bonds. I mean 2 carbon is left, which is formed with hydrogen atom, and this carbon also formed 2 bonds, and 2 bond is left, which is formed with hydrogen atom. Similarly, this carbon, and the last carbon formed 1 bond. I mean 3 bond is left, which is formed by 3 hydrogen atom. Next example. Pent ion. Here the suffix is ion. Ion means it's a alkynes. Again I repeat, suffix is ion. Ion means alkynes, and pent means root. Pent means number of carbon is 5. So first 5. Write the first 5 carbon atom. 1, 2, 3, 4, and 5. Next, ion. Ion means carbon triple bond. Again I repeat that if in question do not say the exact positions of double bond or triple bond, we must write the double bond and triple bond in the first position. I mean first carbon. Again I repeat this. If in question do not say the positions of double bond and triple bond, we must write the double bond or triple bond in the first carbon. So we write triple bond in the first carbon, and other carbon is single bond. Fulfill the valency. Here carbon form 3 bonds. 1 bond is left. 1 bond is formed with hydrogen atom. Here carbon valency is filled. Here 3 bonds and 1 bonds. I mean 4 bonds totally filled. Here carbon form 2 bonds. I mean 2 bonds is left, which is filled with 2 hydrogen atoms. Similarly, this carbon also form 2 bond with 2 hydrogen atom, and last carbon form 3 bond with 3 hydrogen atom, because it form 1 bond with 1 carbon atom. So 3 bond is left, which is filled by 3 hydrogen atom. Another example. What is this? This is a hept to in. Suffix is in. In means it's an alkene, and root is hept. Hept means number of carbon is 7. So we write first 7 carbon. 1, 2, 3, 4, 5, 6, 7. Next, here the positions of double bond is given. So we can't write the double bond in first position. Again I repeat, here the positions of double bond is given. That means we can't write the double bond in first position. We must write the double bond in second position, because in question the positions of double bond is given. Positions of double bond is given. That means we write the double bond in second position. So we write the double bond in second position. Next another carbon is single bond. Another carbon forms single bond with the other carbon atom. Next, fill the valency. How the fill valency? We again repeat that we fill the valency of carbon with hydrogen. Here carbon form 1 bond and 3 bond is left, which is filled with hydrogen atoms. And here carbon form 3 bonds, 1 bond is left, which is filled with hydrogen atoms. And here also carbon form 3 bonds, 1 hydrogen is left, which is filled with hydrogen atoms. And here the carbon form 2 bonds, 2 bonds is left, which is formed with 2 hydrogen atoms. Here also 2 hydrogen atoms. Here also 2 hydrogen atoms. And the last carbon form 1 bonds. So 3 bonds is left, which is formed with 3 hydrogen atoms. Next हम लोग पढ़ेंगे. Next we learn about isomerism. Next we learn about isomerism in the next video.